Hello, welcome to this video. In this video, we will see normal equations. Normal equations is a method to minimize the cost function j of theta. Earlier, we used gradient descent algorithm to minimize this function j of theta, but that was an iterative algorithm. Normal equation gives us the optimal values of theta in just a single step. To derive the normal equations, we will first transform this cost function into its matrix form. So let's see how we'll do that. As you can see, this is our hypothesis at theta of x equals theta naught x naught, theta 1 x1 and theta 2 x2, and this is equal to x transpose theta. First, we will verify this if this is actually equal to this. If I write the x matrix here, x matrix will be equal to x naught, x1, x2, and theta matrix will be equal to theta naught, theta 1, theta 2. This is a matrix of order 3 cross 1, and this as well. So to multiply two matrices, number of columns of the first matrix should be equal to number of rows of the second matrix, but these are not equal. To make these equal, we need to take transpose of one of these. So let's take transpose of x matrix. It will become x naught, x1 and x2. So the order of this matrix is now 1 cross 3, and order of theta matrix is 3 cross 1. Now let's multiply these. To multiply two matrices, what we do is, this is a 3 cross 1 matrix now. The resulting matrix will be a 1 cross 1 matrix. That means it will have one row and one column. One row and one column. So how do we multiply these? We will take the first element of this matrix, multiply it with first element of this, second element of this row, multiply it with second element of this column, third element of this row multiplied by third element of this column, and add these products. X transpose theta will be equal to x naught into theta naught plus x1 into theta 1 plus x2 into theta 2. Now as you can see, this expression and this expression is same. Now we have verified that this expression is equal to this. Now we wrote the x matrix for a single training example, that's x naught, x1 and x2. For first training example, we can write superscript of 1 here to denote it's of the first training example. But if we try to create this x design matrix for n training examples, we will write it like this: x naught first, x1 of first, x2 of first. It means x naught feature of first training example, x1 feature of first training example, and x2 feature of first training example. Similarly, x naught, x1, x2, but of second training example, superscript of 2 over all of these, and so on up to the nth training example. So this is our design matrix for n training examples, theta matrix, and it looks like this: theta naught, theta 1 and theta 2. This matrix has n rows and 3 columns. This is a n cross 3 matrix, and this has 3 rows and 1 column. This is a 3 cross 1 matrix. Now if we multiply these, the number of columns of first matrix is equal to the number of rows of second matrix. That means we can multiply them, and the resulting matrix will be of order n cross 1. So to multiply these, we'll multiply them in a similar fashion: x naught with theta naught, x naught 1 theta naught plus x1 1 theta 1 plus x2 1 theta. Now we'll multiply the second row with this column, the third row with this column, the fourth row with this column, and the nth row with this column. Similarly, we'll get x naught theta naught plus x1 theta 1 plus x2 theta 2, but of the second training example, superscript 2, so on up to x naught nth training example, x1 theta 1, x2 theta 2, don't forget the plus symbol, nth training example. As you can see, this sum is equal to this. We can write this, this is x theta. We have multiplied x and theta here. We can write this as x of first training example transpose theta naught. Similarly, x second training example transpose sorry, theta. Similarly, xn transpose theta. So this is our x theta matrix. Now that we have got our matrix x theta, what we'll try to do is the matrix of y will be equal to this. This is the matrix of output variables. Now, if we will try to calculate x theta minus this y, we will get x1 transpose theta minus y1, so on up to xn transpose theta minus y. Now we have a formula in matrix multiplication and it goes like this. If we have a matrix Z, transpose into Z is equal to sum of I goes from 1 to n. It's equal to the sum of elements of the matrix. That means Zi. And if we apply the same formula here for this expression, we will get x theta minus y transpose x theta y will be equal to sum of elements of the matrix. The elements of the matrix are these. So we'll write summation I goes from 1 to n x I transpose theta minus y. And if you multiply by 1 by 2 from both sides, now you can see this expression looks similar. This is our j of theta. This is our j of theta. So we can write this expression as half of x theta minus y transpose x theta minus y equals j of theta. Now we have transformed our cost function into its matrix form. Now what we need to do is we need to take the derivative of this function in the matrix form and equate it with 0. Now let's do that. Our j of theta is now half of x theta minus y transpose x theta minus y. Now we'll denote the differential of j of theta like this using this symbol. X theta minus y transpose. So before taking the differential of these terms, we will simplify this a bit. So we will write theta will be equal to, we know that A minus B transpose is equal to A transpose minus B transpose. So we can apply this formula here. We'll write x theta whole transpose minus y transpose x theta minus y. I'll multiply these two terms and I'll take 1 by 2 out of the differential as it's a constant, and we can write this is equal to, now multiplying this to both of these and this to both of these. First I'll multiply this with this and then this with this, and it will become x theta transpose x theta minus x theta transpose y. And now this with this and this with this will become y transpose x theta minus y transpose y. This will become half of del theta. We know that A B whole transpose is equal to B transpose A transpose. Now applying this formula here, we can write theta transpose x transpose x theta minus, and there's another formula, A transpose B equals B transpose A. Applying this here to this term, we'll get y transpose x theta. This will be the same, x theta minus y transpose y. These two terms are similar, so this becomes twice y transpose x theta minus y transpose y. You can write this term as x transpose y whole transpose theta, because this will become y transpose x theta if we apply this rule here. A b whole transpose equals b transpose a transpose. Now using this value in place of this here, we can write half of del of theta. Theta transpose will group these together. Theta, you'll see y. We can write twice x transpose y whole transpose theta, y transpose y. Now I have made these smaller, get more space around here. Now what we'll do is we'll take the differential of each term with respect to theta. So we have a formula that's like this: differential of b transpose theta with respect to theta is equal to b. Differential with respect to theta, theta transpose a theta is equal to a theta. Now we will use these two formulas and apply here, take the differential. So I'll write, so taking the differential of the first term, this is of the form theta transpose a, where a equals x transpose x, theta transpose a theta. This is of the form this, and is equal to 2a theta. Here a is x transpose a, so this will become 2 x transpose x theta minus twice this term is of the form b transpose theta, differential of b transpose theta, which is equal to b. So here b is equal to x transpose y. This term does not have theta in it, so differentiating this term with respect to theta will be equal to 0. And this is a positive term, sorry, we forgot to, this is plus sign here, sorry. So 2 and 2 will cancel out, this will become x transpose x theta minus x transpose y. Now we have got the differential of cost function in its matrix form. Now what we'll try to do is we'll equate it with 0. X theta x transpose x theta minus x transpose y equal to 0. X transpose x theta equal to x transpose y. Theta will be equal to x transpose x inverse x transpose y. Now this is the normal equation. By using this single step, if we have the design matrix of, that's the matrix of features and the matrix of output variables, that is the price in the case of housing data, we can get the optimal theta in just a single step. Theta is equal to theta naught, theta 1 and theta 2. So that's it for this video. Thank you.